Welcome to solving trig word problems, part 2. All right, so here we have a problem to solve from the top of a lighthouse 165 feet above sea level. So I'm going to underline some of these numbers here, these measurements. The measure of an angle of depression of a boat at sea is 35 degrees. So we have top of the lighthouse, angle of depression. Oops, my line is awful crooked. Let me underline that a little nicer. Measure of an angle of depression, 35 degrees. And find to the nearest 100th foot the distance from the boat to the foot of the lighthouse. All right, so we have some measurements. We see some things that we're asked to find. All right, it's a good idea to underline those so we know what we're working with. And secondly, we need to make sure we draw a picture. Right? So the first step is we underline some of those key words, or maybe we'd write them down if we couldn't underline them. Right? And then secondly, we need to draw a picture. Right? So we have a lighthouse here. Right, there's my lighthouse. Such a beautiful lighthouse. Right, it's got a little light on top, maybe a little ledge so you can walk around. Right, and so lighthouses, of course, are near the water. And on this water, there's a boat. Right, so there's a boat at sea. Right, so we're looking, we've got from the boat to the top of the lighthouse, and the sea to the lighthouse, from the boat along the sea there to the lighthouse, makes a right triangle because objects are perpendicular to the ground. Right? So let's see if we can put some measurements in here. So let's look at that first one, 165 feet above sea level. What would that be? It says from the top of the lighthouse, 165 feet from sea level, above sea level. That's got to be our lighthouse. It's our lighthouse that's 165 feet. The measure of the angle of depression, right? So angle of depression looks down, right? So it's not going to go from the boat to the lighthouse because that'd be looking up. It's going to go from the lighthouse to the boat, right? So this is where our 35-degree angle should be. And we want to find the distance from the boat to the foot of the lighthouse. Well, the foot of the lighthouse is on the ground, or in this case near the water, right? So this is the length, the measurement we're looking for, right? Not to the top of the lighthouse, but to the foot of the lighthouse. All right, so now so our second step is we drew a picture that matches the information in our problem. Third step is we want to label the sides relative to the angle we're given. Right, so x here is the opposite side, 165 is the adjacent side, and then we want to write a trig ratio for our problem here. So opposite and adjacent, that's going to be tangent. So tangent 35 equals x divided by 165. We need to isolate x, so we're going to multiply both sides by 165. So we have 165 tangent 35 equals x divided by 165 times 165, right? That will cancel out that division there. And so we have 165 tangent 35 equals x. Now at this point you can use that table and plug in the ratio for the 35-degree, the tangent of a 35-degree angle, or you can use a calculator. Both are giving you the same answer and doing the same thing. All right, so I have 165 times tangent 35, and that's going to be 115.534. So x is 115.534. Don't forget your units because these are real world problems, and so that would be feet. Okay? And I'm generally fine with whether you round or don't round, but you know, in case it's a test, maybe a benchmark or something like that asks you to round, let's follow the directions and we'll round to the nearest 100th of a foot, which means that would be 115, that would round down, 0.53 feet. And there we have it. We have answered the first question. So really the only new part is just combining how to interpret the problems to create our right triangle so that we can set it up and use trig ratios to solve. Right? So the only new part we're adding is just how do you take the word problem and make it a triangle. Let's look at the next problem. At a point on the ground 39 meters from the foot of a tree. So I've got a tree here. Oh, that's a lovely tree. And there's a point on the ground 39 meters away. The measure of the angle elevation to the top of the tree is 42 degrees. Okay, of course, the tree forms a right angle with the ground, and that's supposed to look like a right angle there. Right? So let's place our measurements in here. Let's actually underline our measurements so that we can make sure we put everything in the triangle. All right, so we are 39 meters from the foot of a tree. I kind of just added that as I was drawing it along, right? Because that's all kind of one sentence there. We have the angle of elevation, 42 degrees. We have find the height of the tree. All right, so what we're looking for is the height of our tree. Now we just got to figure out where to put the angle. All right, so angle of elevation looks up. Right? So angle of depression looks down, angle of elevation looks up. So our angle is going to be right here. Now all we have to do is label our our sides relative to our angle. So the x here is opposite our given angle, and the 39 meters is adjacent to our given angle. All right, so now we'll just use a trig ratio to solve. Opposite and adjacent, that's tangent again. Right? So we have tangent 42 equals the opposite side over the adjacent side. Right? We need to isolate x, so we'll multiply both sides by 39. So we have 39 tangent 42 equals x divided by 39 times 39. That cancels. So we have 39 tangent 42 equals x. We can now just plug that into the calculator to find the height of our tree. So 39 times tangent 42 is going to give us 35.116. 0.116, and that was meters. That's the height of our tree. And this one said nearest hundredth of a meter, so that would actually be, that would round up, so that would be 35.12 meters. And there we go. We've answered another problem, right? It's just as easy as that. I think I've got maybe 3 more. Let's do another problem. Right, so we have a school is 61 feet high. Right, school. The distance to the road is 170 feet. And we want to find the angle of depression from the top of the building to the. I think this helps give you some context. That's why I kind of like to make things look like what they are as opposed to just drawing a triangle. That helps me set that up. So here we have the school. And the school is 61 feet. So it says a school is 61 feet high. So that 61 must go on the school. The distance to the road, I guess we need a road. Here's our road. That's the road. So the distance to the road is 170 feet. And of course, we're going to measure along the ground, right? The road isn't going up in the air. Right? This is supposed to look three-dimensional, but it's two-dimensional. It's supposed to look three-dimensional, but this is a two-dimensional surface, so my road kind of looks like it's going up in the air. But we know it's not. That's on the ground, right? So if we're measuring from the school to the road, that's along the ground. And that's 170 feet. Right? And then from that point, we can go up to the top of our school to create our right triangle. So the only thing we need now is angle of depression. So notice it says what is the angle of depression? That's our variable this time. And of course, angle of depression looks down. Right? I'm actually going to move my 61 feet because it's kind of in my way, because here's where my angle of depression goes. Right? Angle of depression looks down. So from our angle, we need to label our sides. Right? So across from that theta there, that variable, we have the opposite side. And next to that angle, we have the adjacent side. So opposite and adjacent, I must have been on a tangent kick because this is another tangent problem. So we have tangent theta. The only thing different is this time we're solving for the angle. So tangent theta equals opposite, which is 170, divided by the adjacent, which is 61. Right, we need to isolate theta. So to undo tangent, we're going to take the arctan of both sides. So we have arctan 170 61. There we go. Right, arctan and tangent cancel. That gives us theta. And now we just need to take the arctangent of 170 61. That means we have the ratio. We want to find the angle that goes with that. We could use the table, right, and round to the nearest degree. But the calculator would be a little easier on this problem. So I'm just going to hit second tangent and then 170 divided by 61. It'd be nice if I had a calculator that you could see up here. It would mess up my recording probably. Anyway, and that is 70.2608. I'm going to call it 70.261. Doesn't really ask me to round to anything particular. So 76.261 degrees. There's our angle measure. If you were using the table, you would be able to get 76 degrees from that, but not the decimal that comes after it. Right, so we have a few more decimal places when we use the calculator. So there's that problem. Okay, so this time we solve for an angle. So we use an inverse trig ratio. Right, let's solve another one. So the angle of elevation to a building in the distance, so I guess I'll draw a building here. Here's my building. Isn't that a lovely building? That is a lovely building. There we go. Building, right, is 22 degrees. You note that the building is approximately 450 feet tall. Estimate the distance to the base of the building to the nearest foot. All right, so we're looking at angle of elevation, 22 degrees. We're looking at the building is 450 feet tall, and we want the distance to the base of the building. Right? So that's going to be along the ground because the base is at the bottom. Right? So we're looking for, right, so it's asked us to find this, we're looking for that. We know the building is 450 feet. Now we just got to make sure we place our angle in the right location. Right? So it says angle of elevation. Angle of elevation looks up. So it's over here looking up because, of course, that's the right angle. All right, so now let's label our sides relative to our angle. The 450 feet across from that angle is the opposite, and next to that one is the adjacent. And what could it be? Oh my gosh, it's tangent again. I think the last one's not tangent. So we have tangent 22 equals opposite, which is 450, divided by adjacent, which is x. We need to isolate x. Right, so we have to first get it out of the denominator, so we're going to multiply both sides by x. So we have x times tangent 22 equals 450 times, divided by x times x. That cancels. So we have x times tangent 22 equals 450. Right, and now we just need to isolate x, so we'll divide both sides by tangent 22. Right? So now we have x equals 450 divided by tangent 22. All right, so I'll plug that into the calculator and see what the distance will be. So 450 divided by tangent 22 gives me 1,113.789. So 1,113.789. All right, and this said to the nearest foot. All right, so that would be, and actually I should put feet here too. Right? So if it doesn't tell us to round, we can leave it like that. If it tells us to round, especially if it is like a state test or benchmark, we should really round to 1,114 feet because that would round up. And there we go. We have now answered this question. Ooh, I'm at 15 minutes. Well, I only have one more problem for us. One more. And that's this one here. Right, so an airplane climbs, here's my airplane, climbing into the air. Right, so got the body. I drew this so beautifully in class today. Not as nice, but good enough. There's our plane climbing into the air. Right, and so we're looking at a triangle formed by our plane, the ground. Right, and if we go straight down, right, so triangle here formed by the plane and the ground. Right, so let's underline our key words here. We have an angle of 15 degrees with the ground. We want to find the distance it's traveled. It has an altitude of 1,000 feet. All right, so altitude is always perpendicular, right, to the base, right, to the ground in this case. So this is the altitude. It's a straight vertical height of our plane. So 1,000 feet is the altitude. An angle of 15 degrees with the ground. The ground is at the bottom. So, right, here's our ground. All right, so there's our 15-degree angle. Now we have to figure out, where does our variable go? What is it we're looking for? The distance it's traveled. Well, if I'm trying to figure out how much fuel my plane needs, I need to know the exact distance it's traveled. And the distance it's traveled is where the plane goes, not necessarily the distance it covers along the ground. Right? So the distance the plane travels is x there, right? The way the plane's going. Let's label our sides relative to our angle of reference here. So across the triangle we have the opposite side, and of course this is across the right angle, so this is the hypotenuse. So this is not sine because we have the hypotenuse. Excuse me, this is not tangent because we have the hypotenuse. It's sine. Right, we have so many tangent ones. This one is sine. Sine uses opposite and hypotenuse. So we have sine 15 equals the opposite side, which is 1,000, divided by the hypotenuse, which is x. Multiply both sides by x. So we have x sine 15 equals 1,000 divided by x times x. That cancels. So now we have, I should give myself a little bit more space. Okay, come over here. We have x times sine 15 equals 1,000. We still haven't isolated our variable because we have this sine 15 with it. So we're going to have to divide both sides by sine 15. That gives us x equals 1,000 divided by sine 15. And if we plug that into the calculator, divided by sine 15, we get 3,863.7. The number after that is 0.3. We can include that as well. 3,863.703, and this was in feet. So that's how far our plane has traveled. There we go. We have now solved all the problems in this lesson. The only thing left in this lesson is that there was a closing for you. I will post this closing on Schoology in the little folder that says closings, and you answer my question on your closing side of your bell work. Other than that, this is the end of my my podcast. So I hope you enjoyed it, and I hope it helps make solving trig problems really easy for you. And if not, ask me questions in class. All right, bye for now.